Hello everyone. I wanted to go over this the binomial distribution Excel lab with you. Kind of go through how do we go about building a binomial probability distribution and then using both the individual probabilities and cumulative probability distributions in Excel. Okay, so here's what they're asking us on here. Let me kind of zoom in a little bit more. This is not working well. A surgeon regularly performs a certain difficult operation. The probability of success for any one such operation is 73%. 50 of these operations are scheduled. Okay. So this is the basic signature of a binomial probability distribution. I'm given some probability of success or a proportion that you would be expecting out of a population. And then I'm saying I'm going to go in there and I'm going to grab a set number of trials or a big sample, because I'm like taking a big sample. And then I'm saying out of this group that I'm pulling out of the population, what would be the probability of a particular number of those either operations or, what would be successful from 0, where none would be successful or have that characteristic, all the way down to all in the group would be successful or carrying that characteristic. Okay, so let's kind of go through this using Excel and seeing what they're asking us to do. Okay, so here it says use Excel to construct a probability distribution table to represent the binomial situation. Include columns for possible values of x, individual probabilities of x, P of x, and the cumulative probability where this is P of x less than or equal to x. So I'm going to go up here and I'm just going to do me a header that there's my x. Here's the probability that that particular value for that outcome. And then here's my cumulative. And the cumulative P is going to look like x less than or equal to, so my big X less than or equal to whatever that value is. Okay. So that's kind of what they're using in here. Okay, so let me go back over, click on this, and we'll fill this in a minute. So to what you're doing, you're going to go through whatever the number of trials are. Here I've got 50, so I'm going to generate this table 0 through 50. 0 represents that out of those 50, they would be, none of these surgeons would be successful. Out of that many, 0 would be successful. So here, I'm going to go all the way through all the possibilities between 0 and my 50. Now I'll go back up here. There's my 50. And this would be saying all 50 of these operations would be successful. Okay, so now I just use, in Excel, I'm going to go binom.dist, binomial distribution. The number S means the number of successes. Well, I'm going to click on that and say use that particular value as my number of successes. Here's my, out of 50 operations, those are my number of trials. The probability of success, well, that's the proportion that are usually successful, the 0.73. And for individuals, I use this as 0 or false. Okay, if I selected a 0 there. Okay, so here if I highlight, I'm saying the A2, what's in A2, that's my number. Out of 50 trials, probability is 7.3. Give me the exact probability of that number. And then all I got to do is go in, and then I just drag, and then that fills this in. So for each one of these, once I do the fill handle, now it says use A3, the probability of exactly 1. Probability of A4 is this guy, the probability of exactly 2. Okay. So when we're doing the cumulative, I'm going to do the very same. I'm going to fill out everything the very same. The number of successes, that's in that cell. The number of trials, well, that's the 50. The probability of success, we're still at 0.73, no change there. But here I'm going to say cumulative probability distribution, And what that's going to do is going to give me the probability that it would be less than that number. Okay, so I'm going to drag, and this first one is the very same thing, but this number is a little different, and it's saying the probability that x would be less than or equal to 1. That's this. Okay, so 1 or less. So it sums up these two probabilities, kind of that or situation, 0 or 1. Here would be the probability that it would be less than or equal to 2. So again, this or this or this. So I add up my probabilities, and that's what the cumulative is doing. And then pretty soon we get out here and we get exactly 1. Okay. So it says find the probability that exactly 40 operations are successful. For exactly 40, I would use the column where it doesn't accumulate, go to 40, and that would be that value, exactly 40. This would be less than or equal to 40. Okay, so I'm going to highlight that one because it says it wants us to highlight. And then it says find the probability that at least 40 operations are successful. Make sure that this was correct. Okay. So it says it wants to know the probability that at the very least 40 are successful. Okay. At least 40 is 40 or more. So what I really want to know, the probability x greater than or equal to 40. That's that. But it says it wants to use the rule of complements. So if I did that, I would want to say 1 minus all of these things, but that one number represents that sum. So I'm going to equal 1 minus, and I'm going to write this up here. So let me redo this as saying 1 minus, and then I'm actually going to do it. The probability that x is less than or equal to 39. Okay, and that's exactly what this is. So I want to subtract off all of this, and that's what this is the sum of all of these things. So I'm just going to go equal 1 minus, and if I go up here and click on this, it'll do that calculation for me. So that's using the rule of complements to get that number. Okay. So now it wants us to do the expected value, which is the mean. And I'm just going to write E of x up here. And that's just the n times p for a binomial distribution. It turns out to be n times p. So I'm going to go equals, remember the probability of success was 73 with 50. So I'm going to go back up here, 0.73 times 50. And that gives us the expected value of 36.5. The standard deviation is the next question that they ask. And I've got to do the square root. So I'm just going to indicate this by SQRT, the square root of NP 1 minus P. Those are multiplications when I do that. Okay, and I have to do a double one. Here, the 2 parentheses, this one closes up that 1 minus P in here. So I'm going to go equals SQRT. My N was my 50. My P was my 0.73. Then times 1 minus 0.73. And then that gives me, I put the 2 parentheses, one closes the 1 minus P, and then the other one closes the square root. So the SQRT, that's Excel's version of taking the square root, the radical sign. Okay. So we did the standard deviation, and now construct a probability histogram. So it says make sure you just do the individual probabilities. So I'm just going to select these 2 columns all the way through. And then if I insert my recommended charts, I'm going to select this one because this looks really nice for probability distributions. And if I wanted to, I could format my data series, and you should, doing a histogram. That kind of butts those things up together. So notice this is a left skewed, the data, you know, most of the data is out to the right, but I've got the skewness out to the left. And it looks so left skewed, but almost bell-shaped in the middle. So bell-shaped with some left skewness, okay, with those characteristics, okay. So we're going to go on and we're going to continue with a different problem. So I'm going to rename this sheet. I'm going to do that one as surgeries. And then I'm going to go to a new sheet down here. Let's go ahead and rename this. This is going to be penguins. And then I'm going to go through with this problem. So problem 2 says the survival rate for emperor eggs is 19%. There are not 100 penguins and a wattle that lay an egg this year. So I've got 100 penguins, they lay an egg. The survival rate for these eggs is 19%. That's the signature that you're going to start looking for a binomial distribution, because it's going to ask you as we go through, what's the probability that a certain number are successful or less than, more than those numbers out of that group of 100. Okay, so we need to generate that X, probability of X, and then the cumulative P of X. So here again, we're going to go 0, 1, and I need to generate 100. I don't want to type all those out. So I'll let Excel build this list for me. And this looks really well for a binomial distribution problem. I need to go to 100. So that gives me that. It kind of gives me where I'm at. The probability, we're going to do the very same thing that we did before, the binom dist. I need which number of successes. Gives me the number of successes, exactly 0, 1, 2, 3. 100 trials. The probability of success is 0.19. 19% carry this characteristic of surviving. And then here for the cumulative for the individuals, I don't want to accumulate, so I can do the false. And then I let the fill handle kind of increment what's going to increment. That A2 is going to increment as I pull down to A3, A4, A5. So I'm going to let that do, and then I'm going to do all the way down. The cumulative is equal to the very same thing. It's the very same function. Again, there's my number of successes. That's what the number S does, the number of successes out of 100. My probability of success is my 0.19. And here I want to accumulate. So I do that one, close the parentheses. And this now is the true. There's my number of successes. And here it's going to accumulate and add the previous versions. Okay, so here it starts going out to 1 here. So the probability of 0 or less, well, there's only 0. It's just that very same thing. So this is exactly 0. But here the probability of exactly 1 is this column. This is the probability of either 1 or 0. I've added up. I've accumulated this plus this. 2 or less, 3 or less, so I've added up all of these things. Okay, so now let's see what it's asking us based on the binomial probability distribution. What is the probability that exactly 25 eggs? That's kind of what the binomial distribution does for us. It allows us to say out of a particular number, if we have some known success with the characteristic, what would be the probability of exactly a certain thing, and then we can analyze it. Okay, so it says exactly 25. I'm not going to use this cumulative. That's the exact one, and all I want to do is just highlight that one. So there's my highlight. Okay. What is the probability that at least 25? At least 25. It's asking for the probability that X at least 25, that's the very least. So it could be bigger than or equal to my 25. Okay. So that would be this plus this plus this. So I'd have to add up all of these things and do a summation. Okay, so that's doable when it's Excel, but we can make it a simpler calculation if we were just doing it. Since we've already got the cumulative, this is really, so I'm going to do it without the equals first. 1 minus the probability of X less than 25, which is the same thing as 1 minus the probability of X less than or equal to 24. Okay. I want these subtracted off. Okay. To give me, I know everything's going to add up to 1. If I do all of these things, all this stuff is going to add up to 1. So I'm going to subtract those off from the 24. So all I have to do is go equal 1 minus the 24, this is the summation from all of those previous ones. So I just click on that and that gives it to me. Okay. What is the probability that no more than 20 eggs hatch? No more than 20. No more is the probability that X is less than or equal to 20. That's no more. And that's just, I go up here and I can do this, the accumulate, because that is all of these, X less than or equal to 20. Well, it could be 19. All of these things, if I'm doing or. So I'm just going to go over here and do the accumulate, and it's that number. And it says highlight those things. So let's do the 20 and then highlight to show where we're getting this number from. What is the mean number of eggs expected to hatch and survive? So here's my expected value, E of X, that's what we call the expected value. And again, that's just the NP. So it's equal to, out of the 100, and a success rate of 0.19. There's 19. So here, look at it, the probability start low. They're starting to peak right about that area, and then they drop off. Here's the highest probability. In fact, that's what we are expecting right in there. Okay. But we have some deviation, different 100, they're going to be different things. So what would be that standard deviation from that mean? And that's going to be the SD. And that again is the SQRT, the square root of NP times 1 minus P. And we're going to have to close that up. And I'm going to open that up just a little bit here. I didn't need to do that. Open that up just so we'll have this. So this is going to be equal to square root. Excel, calculate the square root of 100 times 19 times 1 minus 0.19. The other percentage. The percentage of not successful is what that is, basically. And that gives us a 39. I didn't get my point in here. That looked like a pretty wide. And there we go. So 100 times 0.19 times 1 minus 0.19. The square root of these numbers, that's the standard deviation. Construct a probability histogram. Again, I'm just going to grab this not for the cumulative, but for the individual probabilities, insert recommended charts. And again, I like this one down here where it's got lines up here, and that kind of gives you a good feel. So if I click on this thing and then format my data series, right over here, I had it. It just didn't show up. If I go to my gap width, then I reduce my gap width, then we got it. Okay. And that's what we're kind of expecting over here. Let me kind of drag this thing up a little bit. Okay, so notice this is out skewed to the right. Okay, there's data way out here. If I start getting the mean, if this was perfectly symmetric, the data, the mean would be right up in here, and then it's going to get pulled out because I'm averaging in numbers further out this way. Okay. So that's the histogram, and then it asks you to describe the shape. And here are some general questions that you're asked based on probabilities. Would it be unusual for exactly 13 eggs to hatch? So if I go back up here, exactly is that number. That's that particular value. And it's given the probability that exactly 13 out of those 100 would hatch would be 0.03265. When we're talking usual and unusual, we're using the 0.05 as our checkpoint. This is less than 0.05, so this would be unusual. Okay, 0.05 or more would be usual, so that would be unusual. Okay, highlight this value in red, so you would go here, home, click on this, go down here, give me a red, maybe a little lighter red so I can read it. And then that would be that value. And then it says, would it be unusual for 13 or fewer? 13 or fewer. So I'm going to look at the probability out here, the probability that X would be less than or equal to my 13. And that's all of these together. So this would be any of these things. So I would add up all of these things. That is this value. And that is bigger than 0.05, so it wouldn't be unusual for 13 or less to be hatched. Okay, but that would add up all, so that's a bigger a bigger version of, it could be 0, 1, 2, 3, 4, 5 when you make this statement. So all of these probabilities add in that OR situation. Okay, so clean that up a little bit. Turn this in as your group, and we'll see you next time. Hope this helped.